How can you know that the Pythagorean theorem works for all right triangles? In this lesson, you will learn how to prove the Pythagorean theorem by using similarity. So let's review. An altitude is a line which passes through a vertex of a triangle and is perpendicular to the opposite side. So we have our triangle, and we draw a line through the top vertex to the opposite side, and it hits the opposite side at right angles, or is perpendicular to it. We then have an altitude. Also, the angle-angle postulate states that if two angles of one triangle are congruent to the corresponding angles of another triangle, then those two triangles are similar. So in our core lesson, to prove the Pythagorean theorem, we're going to go through an investigation and a series of steps. So for step 1, we're going to cut a 4x6 card along one diagonal. And this produces two identical right triangles. For step 2, we're going to draw an altitude from the right triangle to the hypotenuse on both cards, but I'll show one here. Then we're going to label each triangle. We'll label the vertices A, B, C, and label where the altitude hits the hypotenuse AB, label that intersection point D. We'll also label the sides A, B, C, lowercase because they are sides. And you notice that side C, the hypotenuse, is broken up into two parts, a larger part and a smaller part. So we're going to label those part Y of C for the larger part and part X of C for the smaller part. If you notice, we have created 3 similar right triangles. The larger triangle compared to the smaller triangle, they both share angle B. They also are both right triangles, so by the double angle or the angle-angle postulate, these two triangles are similar. So if we compare the larger triangle to the medium triangle, they share angle A and also have right angles. So by the double angle postulate, they are also similar. So step 4, we're going to cut one triangle along its altitude. So here's one of our triangles. If we cut it along its altitude, we've created 2 more triangles, or we've split them apart. So we've got the medium triangle and the smaller triangle. So step 5, we need to arrange the triangles so that they are all oriented in the same direction. So we're going to orient them so that the right angle is in the bottom left corner. So the largest triangle here, we see that the right angle is down and the hypotenuse is labeled C, where remember that's part Y plus part X. Its shortest leg is A and its longest leg is B. For the medium triangle, again its right angle is in the bottom left and its hypotenuse is labeled B and its longer leg is labeled Y. The smaller triangle, its right angle, bottom left again, and its hypotenuse is labeled A, and its shortest leg is labeled X. So now for step 6, we'll take the 3 triangles and write proportionality statements. So here's our 3 triangles, and we'll start with the medium triangle proportional to the largest triangle. So here we see that if we compare the 2 hypotenuses, we get the ratio of B to C. And if we compare the longer legs, we get the ratio of Y to B. Now we'll compare the smaller triangle to the largest, and we compare the two hypotenuses and get the ratio of A to C, which is equal to the ratio of X to A of the ratio of the shorter legs. So now in step 7, we're going to use algebra to solve for X and to solve for Y. So starting with our first ratio of the medium triangle to the larger triangle, if we multiply by b on both sides, this will get our y alone, and we end up with b squared divided by c equals y. And then we use our second proportion of AC equal to XA, multiply by a on both sides, and we get a squared divided by c equals x. So if you remember, x plus y equaled c in our largest triangle. So if we use that, we can substitute in what we just computed to equal y and to equal x. So when we substitute those in, we get this algebraic statement. Also, we know that when we add two things together and divide by the same quantity, we can combine those algebraically like this. So a squared plus b squared divided by c equals c. So now if we multiply by c on both sides, we get rid of our denominator, and we have a squared plus b squared equals c squared, or the Pythagorean Theorem. In this lesson, you have learned how to prove the Pythagorean Theorem by using similarity.